Okay, Jai Hind everyone. I am Achintya Pandey as an assistant professor in IT department at Akgec Engineering College. Today I am going to discuss about the transaction management. Okay, it is in the DBMS 4th unit. Okay, so what is transaction management? How the transaction is going to manage and all that, right? Where the variables are going to update, right? Where the data are going to update, right? So we can say that there is a transaction. So the objective is to explore transaction management concept of database management system. Okay, so what is a transaction? So a transaction is basically a unit of program execution that access and possibly updates various data item. For example, say if you want to, transfer say $50 from account A to account B. So how you could write the sequence and all. Okay, so here if you want to write I mean just as a simple code, so you can write for example like you are going to transfer $50 from account A to B. So if you are going to write, you can write like you would have to say data item A and B. So one account is A, another is B. So you can write like read A equal to A minus 50, write A, then again B, read B equal to B plus 50 and write B. Okay. So wherever the variable are going to change, update or just data, I mean data is going to update. So we can say that there is a transaction. So this is basically a unit of program execution where that access and possibly update the data item. So a transaction must see the consistent database. During transaction execution, the database may be inconsistent. So we need to ensure that the database must be consistent. So how we are going to do that, we will see in this concept. Okay, mainly two issues comes which need to deal with. First, if transaction at any moment fails, I mean due to any reason, say hardware failure or for example interrupt or anything. Okay, so how the if the issues are failure of various kinds such as hardware failures or system crash. Next is concurrent execution of multiple transactions. So many transactions at a time are going to execute. So how we can deal the concurrent executions, because data item can be updated or can be viewed by so many transactions, so many process. Okay, so how we are going to deal with that, we will see in this transaction. Okay, so basically transaction, there are four property of transactions which need to be ensured while going or maintaining the transaction. So these four property are very important. These property are called ACID property. So A stand for atomicity, C for consistency, I for isolation, and D for durability. Okay, so atomicity means say either we can say atomic instruction. So atomic instruction means either the instruction execute as a full, means the whole execute instruction, say it could be of 4-5 line, it doesn't matter the number of line, but if it has an instruction, so it will fully execute. Okay, so transaction in atomicity must be executed. So either it will execute full or not. Okay, so atomicity property say either all operation of the transaction are properly reflected in the database or none are. Okay, for example, see here, if it is a transaction like transfer of $50 from account A to B, so you could write like this. Okay, so atomicity says either the whole, I mean these all 6 line executed as a whole. It could not be like 4 operation being performed and it is suspended for 5 and 6. No, either this will behave as a unit, as a single. Okay, so means all these 6 operations must be performed or none are. Then we can say It could not be the case like account A has been deducted by 50 while B is not being updated by plus 50. Okay, so it could not be case. Suppose if you want to transfer $50, so it should not be one account being deducted and the second account, recipient account, being not updated. This could not be the case. So that is very important property of the transaction. Atomicity property says that the whole operation, you can say it is as a instruction. So instruction execute atomically. The whole must perform or none are. Okay, so that property is called atomicity. Consistency means the update. If you are going to make changes, so they should be consistent before operation. Suppose here the data item are A and B. So after executing all these, the sum of A plus B should preserve before updating and after updating. Okay, the sum must preserve the same value. Okay, it should not be there is one account be deducted. Like suppose if the value of A is 1000 and B is initially 2000, so then if you are going to sum the value of A and B, it could be it will be 3000, right? Suppose these operations are going to perform. So this is before this transfer, right? So the sum of A plus B will be 3000. Now after performing this operation, after transferring $50 from account A to B, if we are going to sum A plus B, it should not be 3050 or 2950. It must be 3000. So here suppose if A, so this become 950, but this become B plus 50 means 2050. And if you are going to sum this whole thing, so it will again become 3000. So that is called consistency. Consistency means the value before the operation and after the operation, sum of data item must be the same. Okay. So execution of transaction in isolation preserve the consistency of that database. It must be in consistent. Okay. Isolation say although multiple transactions may execute concurrently, each transaction must be unaware of other concurrently executed transaction. Means suppose there are so many transactions. Okay, say there are n transaction like T1, T2, Tn, but T1 must feel, T1 should not bother about T2, T3 and T4. T1 should be like that it is executing in a isolation mode. Although there are so many transactions are executing, but T1 should not be aware about, T1 should not be bothered for T2, T3. T1 itself think like it is executing in a isolation way. So third one is isolation. Fourth one, durability. Durability means if you are going, if there is some change, so that change must be durable, that change must preserve. So after transaction completes successfully, the changes it has made to the database persist even if there are system failures. Okay. This is the example of fund transfers. So what is transaction? So transaction is basically unit of program executions and that access and possibly update various data items. So wherever the variable or data item are going to change, we can say there is a transaction and this must satisfy all these four property: atomicity, consistency, isolation and durability. Okay. Next one is transaction states. You can just relate a transaction just as a process. Okay. Here we talk about in the context of database. So this transaction is just like a process. So there are so many states of process. Okay. Processes are program under execution. Here we are just talking about updating. Okay. So transaction state just like process states. So program under execution may be in various state, like it could be new, ready, running, blocked and terminated. Similarly, transactions are in this phase. This is called active, partially committed, failed, aborted and committed. Active means transaction just been started, okay. Partially committed means all the operation been performed, the end of the line. Like if this is a transaction, so when write B is performed, we can say this is partially committed. This is the first operation, I mean first line of this transaction, and this is the last line. So when the last operation, last line of the transaction been performed, then we can say this is partially committed. So the end of the operations, okay. Then it could be after partially committed, if we commit operations, we write, so that state become the committed. And if the transactions somehow going to fail before, say at any point, say at 5th point, 4th point, the transaction could be fail. So this can come failed state. So from partially committed, even it is the last line of the transaction, but that could be failed. Before commit, even it could be failed. From active, from at any point, from initial to last, at any point transaction can be failed, then that state could be called a failed. So we can see that the failed state could be from partially committed even, or even the active state, means at any point the operation can be failed. So how it is going to be, right? So that state is called failed. So if the transaction is going to fail, that is aborted, okay. So these all are the various states. There are 5 states, like just like process, new, ready, running, blocked and waiting, okay. End, sorry. So this is the various state of transactions. And if transaction is going to fail, then how we could recover? So there are rollback and all techniques are used to recover, because the property of transaction, like acid property, must preserve, okay. So how we could implement the atomicity and durability? So there is a scheme that is called shadow database scheme. So the recovery management component of a database system implement the support for atomicity and durability. So the scheme is called shadow database scheme. So here we assume that only one transaction is active at a time. A pointer called DB pointer always point to the current consistent copy of the database. So all updates are made to shadow copy of the database, and DB pointer is made to point to the updated shadow copy only after the transaction reaches partially commit and all updated page have been flushed to disk. In case if transaction failed, old consistent copy pointed to by DB pointer can be used and the shadow copy can be deleted. So meaning is that here the shadow database means parallelly a copy of the updates is maintained, okay. So wherever the transactions are written, I mean suppose these all are the operations. So it is going to perform in memory. Parallelly a shadow copy is maintained, so that at any point if it is going to fail, so we can simply undo and redo the that copy, and the main I mean changes which is going to reflect in database should not affect that, okay. So by using like you can say this is the old copy and this is the new copy of database. So we maintain some another I mean copy of the database, so that if there is a change, so that particular copy is deleted. Original copy is already there, okay. Next is concurrent executions. So we can see that to achieve increase I mean processor and disk utilization, we need to have concurrent execution. So let me clear about what are concurrent executions. So there are three things. One is serial execution or sequential, second is concurrent execution, and third one is parallel execution. Serial execution means one after another. In terms of process or even transaction, serial execution means say if there are transaction T1, T2, T3. Serial means if T1 complete, then and only T2 start. That is called serial. Or T2 finish, then and only T3 start. Kind of that. That is called serial. One after another. Until T1 doesn't complete, T2 cannot be start. So this is called the serial sequence. Once one complete, then and only second start. Concurrent means there is a overlap of executions. I mean, suppose there are three transactions like T1, T2, T3, and these all are the sum operations. So we can say suppose 3 line of T1 execute, then it switch to T2. Say 2 line of T2 execute, then it move to T3. I mean, say 3 line, then again resume to T1 and all that. That is called concurrent executions, because we want the execution must be fast. Okay, so if the execution remains serial execution or sequential execution, this could be very slow. So in practical, there are concurrent executions. Okay, hundred and thousands of transactions are executed concurrently. So the concept is, or the main thing is, there are fast switching. Okay, there are overlap of executions, and that is called concurrent execution. It seems that all are executing parallel, but it is not the case, right? There is simply switching among the transaction are so fast, or in terms of process, we say the switching among the process are so fast that it really all the transactions are executing parallelly. And in case of parallel, it is like 3 transactions are parallelly execute. So concurrent means there are overlap of execution. It relies that so many transactions are executing parallelly, but the case is there are switching, right? Like 3 line of T1 execute, then T2 execute, then T3, then T1, then T2, means there are switching among that. So if we want speed, less response time, then in general concurrent executions are performed. Okay. So if there are switching, if at any point, like suppose first, this is the first line, this is second, this is third, then T2 transaction are going to start, then again say T1 start, then say T3. So at any point, if switching could be done, then we need to ensure that all the operation being successful perform or not. Okay, I mean there could not be case of false update and all that. So there are techniques to maintain concurrency control. Okay, so that if we are making some changes, that changes should reflect and there should not be any wrong update and all that, right? So how we are going to do that? So before concurrency control, let me discuss what is schedule. Okay, so what are schedule? The schedule is basically sequence of executions. What are the order of the sequence? We can say schedule. Like this is a order. Say if there are 3 transactions, so this is the order. Like first 3 line of transaction T1 execute, then 3 line of T2 execute, then say for example 2 line of T3 execute, then again say 4 line of or 4 operation of T1 are going to perform. So this is the order. Okay, T1, T2, T3, or T3, T2, T1, or T1, T2, T3, then T1, then T2, kind of. Okay, so this is the schedule. So what is schedule? So what is the order of sequence of execution of the operation, or you can say basically the transactions. So schedule are the sequences that indicate the chronological order in which instruction of concurrent transaction are executed. It is a set of transaction that must consist of all instruction of those transactions, and it must preserve the order in which the instruction appear in each individual transaction. For example, this is a schedule like T1, T2. Okay, another schedule is like we have T1, T2, T1, T2. Okay, so there could be many sequences of the transactions. Okay, that is called schedule. Okay, so it is nothing but simply execution sequence. What are the sequence of execution of the operations of various transaction is called schedules. Okay, so how the operations are going to be correct? For example, we say that there could be many switching among the various states. Okay, so how we can say that all the operation been performed successfully, or we can say the correctness of operations. If it is a serial schedule, okay, if it is a serial schedule, serial means if say all the operation of T1 is performed, then and only T2 start, then it is definitely it is correct. In fact, okay, if all the operation of T1 been performed, then and only T2 or anyone is start, then it is there is no point of incorrectness. It is already correct, right? Because there is no switching, and but in real there are concurrent execution, there are switching among various points. Okay, so how we can, how we can make arrangement, how we can manage so that the operation perform will have the correct result or will have the correctness. So if we can make or somehow if the concurrent execution sequence, say somehow if we can manage it some kind of serial schedule, then we can say that it is all the operation will be performed correctly. Okay, so here see here in the example we have two transactions T1 and T2, and the T1 transaction simply transfer $50 from account A to B, and T2 transfer 10% of the balance from A to B. Okay, so simply we could write like earlier we have written, this is the T1 transaction, and in T2 we are simply transfer 10% of the balance. So this is the 10%. So this could be the operations of T2. Okay, so this is in fact the serial sequence. So it will be correct. All the operations performed will be correct. The operations will be correct because T2 start only after T1 complete. But somehow say suppose if after 2 line of T1 it switches to T2, then say after executing 3 line of T2 transaction it switches to T1. So how we ensure that the operations are the update of A and B data item will be correct or not. So if we can we can make that schedule or we can make the schedule so that it could become some kind of serial schedule, then we can say that the transactions operations will be correct. Serial schedules means some equivalent of serial schedule, then all the operations will perform correctly. Okay. So these are the various, the balance in both schedule 1 and the sum A plus B is preserved. Say here it could not be preserved. Preserved means the value of the sum of A plus B before the changes and after the changes, if it is not going to be equal, then we can say this is not the consistent. So how we can maintain all those property of transaction like a acid property? So we make these concurrent schedule into a form of some kind of serial equivalent schedule. So that is called serializability. Okay. So next one is the serializability. How we could make some kind of serial schedule, like if there are 3 transactions or 2 transactions. So the serial schedule could be T1 and T2 or T2 and T1, means all the operation of T2 perform, then and only T1 start, then there is no point of incorrectness of operations. Okay. But here 2 line of T1, then T2, then T1, then T2. Okay. So can we make these, these schedule into an equivalent of some serial schedule? If it is so, then all the operations will be correct. So serializability is nothing but how we can make the concurrent executions into an equivalent kind of serializability. So there are 2 types of serializability: conflict serializability and view serializability. In fact, before conflict serializability, there are conflict instruction. We say conflict instruction. So let's see in the example here how we can make these concurrent schedule into some equivalent form of serializable. Serializable means if somehow these line could be shifted, or you can say if these operation could be shifted here and this comes after these operations. Okay, means if all 4 these 5 lines come below this, means here, then we can say that this is some form of serial schedule like T1 and T2. So how we are going to do that? So there are conflict instruction. Conflict instruction means if the data item are same and one of the operations is right, then we cannot change the order of the conflict instructions. Okay, like here we can say that this is data item A and B. So here data item A, here read operations in T2, here write operation in T2. So if data item say on one of the operation is write operation, then we cannot swap these instructions. If we cannot swap these instructions, it could not be shifted up. Okay. So if it is not conflict instructions, if the data item are different, or simply if it is read A, okay, not read A write A, or not write A write A, okay. If it is not, then and only we could swap these instructions and it could be shifted up. Okay. So conflict instructions, if there are non-conflict instruction, then we could swap those instructions and can be made to some kind of serial equivalent instructions. So conflict serializability say if somehow concurrent sequence could be made some kind of serial equivalent, then this could be said that this is the conflict serializable. Similarly, there are view serializable. So let's see the example how we are going to perform conflict serializability. Okay, like here T1 and T2, can it be like T1 or T2? So see here how we can make these serializability into kind of conflict serializability. See, read B and write A, there are different data item. So these instruction could be shifted up. So read B could be shifted up, means here it could go. Similarly, write B, data item are different. So these all are the non-conflict instructions. So this could also be shifted. So this schedule we can say that this is the conflict serializable. If we can swap the instruction, if we can swap the instruction up, all the instruction of T1 appears before starting of T2, then we can say that this is the kind of conflict serializability. Okay, so for the conflict serializability, what is that? Means if there are non-conflict instructions, and what are non-conflict instructions? So non-conflict instructions are if either the data item are different, okay, then the order of instruction could be swapped, or if the data item are same but at least one operation is write operation, then that instruction cannot be swapped. For example, if it is read B, then we cannot, if it is say write A, then we cannot. Even read A are there, would be there, then we could not swap. So if we could not swap, then it could not make the any kind of serializable. Serializable means, say if there are two transactions T1 and T2, how we can make serializable? How we can shift the operations of T1, either all the operations of T1 comes first, then and only T2 start, or either T2 first start, T2 first complete, means all the operations of T2 should be up, then and only T1 start. If it could be make like that, right, then we can say that these kind of schedule will be conflict serializable. Okay, there are another way even, one is that is called graph method. There we consider every transaction as a node. Like if there are 3 transactions, and so we consider transaction as a node, and we simply see the direction of the conflict instruction, and if it form say cycle, then we can say that this is not the conflict serializable. So one way is this one. This is the shorter way to show that whether the sequence of execution are conflict serializable or not. Similarly, view serializable are there. So these are the, I mean, main concept of transaction management.